The 10.5 stuff will introduce, well, 10.5 to 10.7 introduces polar coordinates and a couple different modes on the calculator. So the big thing for this test will be to make sure you switch your modes properly.
Wait, should we have a separate test just on 10.5?
10.5 to 10.7, yeah. So the difference now about 10.5, 10.7. So today we're dealing with what's called a parametric mode. Before now, every time we've thrown the ball into the air, we can record the height of the ball versus time, or we can record the horizontal distance versus time. Now we can actually put the horizontal distance and vertical distance into one equation. So, a lot of times too, they may give us a range of values to look at for our t, which will be our input. So all we're going to do is take the input from -2 to 5, plug it into the x equation, plug it into the y equation. So when you plug in -2 into the x, remember we're right here, we're just doubling the t value. So -2 times 2 is -4, -1 times 2 is -2, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 8. Who do we appreciate?
Spencer.
No.
Then we're going to do the y equation. So we're going to take our values and plug them into the t squared plus 1. So you're going to square it. 4 plus 1 is 5. Square it is 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 9 plus 1 is 10. 16 is 17. 25 plus 1 is 26. Okay? So there are two separate equations in one parametric group, you could think of it as. On the graph, I'm just going to start with the first point that we put down there. It was 4, 5, right? Or is that negative? Negative 4, 5. So go 1, 2, 3, 4 to the left. 1, 2, 3, 4, 5 up. So that is our first dot. The next one is at -2, 2, which would be about right there. The next one is at 0, 1, 2, 2, 3, 4, 5. What's next? 6. 10 would be about up there somewhere. Whenever you graph parametric, and you probably want to write this right next to this one, whenever you are asked to graph parametric, you must indicate the direction that the graph moves. Okay? Get your calculators out. We have to switch our mode. We're going to go to mode. We're going to go down to function, parametric, polar, sequential. We're sliding over to parametric. So you can see right away when I hit the y equals, how it pops in there. It's got the x and the y. So my first equation was 2t. Now because you switched the mode, this button where you used to get your x variable from has also switched mode, so that's why it puts the t in there. So if you're in parametric mode, it doesn't matter what the variable's name is. It could be H, Q, R, doesn't matter. But when you hit that variable button, it puts the t in there, so it knows that's where you want your variable. And then I already have t squared plus 1 typed in, so you can just hit t squared plus 1. So t squared plus 1. Hit your window. Now the window is a little bit different too because it has that T minimum and T maximum. They asked us to go from -2 to 5. Let's just go by one at a time. Our table just went up by 1. And then X min and max, I'm just going to go zoom standard to switch it to a standard. So, well, -10 to 10 by 1, -10 to 10. It's kind of a standard window. So when you hit graph, it matches the same graph, right? I should record that. So we're going to switch the T step to 0.01. So I got to trick it. So, did you see how it moved from left to right? So if you ever are graphing it, it doesn't really matter what your T-step is right now. But if you can't see the direction and you need direction, I think the calculator is the easiest place to get it. Just make your T-step smaller and smaller and smaller. The more calculations it makes, the slower it has to go. Okay? So we're going to use graphing calculator to do the following curves. So again, they are giving us a range of values. So we'll go back to y equals, what was the first equation? T squared. And the second equation was T minus 1. And this time they're asking us to go from -3 to 3. I just know from the equations we're doing that we can go ahead and keep it at 0.01. So it was this parabola that came in and left again. So we know it came in like this and was leaving like that, but we indicate direction. So we would say it's coming in on the bottom and leaving on top. Always indicate your direction. Anytime you graph parametric, indicate the direction. Just put the little arrows on. There's nothing different here except they're not telling me a range of values for your T. So if somebody's sitting near you, I want you to graph it, parametric, and then indicate direction, and you may have to mess around with the T step. You know, see if you can find a good one.
You got a good workout in it.
Okay, so that should be your graph. What did you guys find worked for your T values? What? -3 to 3 work? That's fine. When in doubt, I tend to go back to like a -10 to 10. But anyway, the direction is kind of, I heard, looks like a bird there, and it comes in from left to right. Yeah. Good.
How do you know which numbers?
Do we have to say if it's a function?
Oh, where does it say that?
It says the zero function. It's not the right one.
Right here.
Yes.
Oh.
Yes, it is a function.
Is it a function? Simply stated, yes, it passes the vertical line test. Good. All right. Now, we get into some what they call eliminate the parameters. We can get into more difficult parametric equations. Now, at this point in your guys' math career, most of you recognize y equals x squared, y equals 3x plus 5. You can tell me one's a quadratic, one's linear, right? You can tell me, you know, the cubic, the absolute value. When I write it in terms of y equals, you should have an idea mentally of what the graph looks like. But in parametric mode, it doesn't really make sense. First of all, for most of you, it's the first time you've seen it. So, a lot of times what we want to do is eliminate the parameter, change into a rectangular mode equation, okay? I think I'm gonna stop and do a new video.